factoring, we know that the first thing we'll look at is get common factor. Then we're going to check something called difference of squares and perfect squares. We'll get to that later. And then the next thing is to check for simple trinomials. Now, I'm going to show you right now a technique that is going to be good for absolutely all this 1, 2, 3, 4, and actually 5, but you can't do it with this, all of them. So it takes a little longer. There's going to be a shortcut coming up later, but just bear with me so you see how one method could actually work for all of them. And that's just organized trial and error. So, first of all, what is a simple trinomial? Simple means that the a is 1. Our general term is ax squared plus bx plus c. Well, if my a is 1, then I basically have x squared plus bx plus c. And that's an interesting case, and it's going to be simple for us. So, if I were to expand this, x plus 3, x minus 4, I would end up with x times x gives me x squared. 3x minus 4x, it's minus x. And then 3 times minus 4, it's minus 12. Okay, so that's expanding. Now if I want to factor this, that means that they would have given me an equation that looks like this. X squared minus x minus 12. And we have to come up with what these two brackets are. Okay, now let's say that I make my first bracket, I'm going to make it green. And my second bracket is going to be red. Pretend the black's not there. So, just by looking at this, I already know that because my first term is x squared, then the first times the first should give me x squared. There's only one possibility, and that is that it is x squared. Sorry, x and x. X and x would give me x squared, and that's good. Now I know that for my last term, the last and the last should give me minus 12. Now I have choices, because it could be 3 and 4, it could be 6 and 2, or it could be 12 and 1. So which one is it? Well, we already know, but let's pretend we don't know. So I'm going to be guessing, and I'm going to guess first that it's going to be 6 and 2. Alright, so then I check. X times x gives me x squared. 6 and 2 gives me 12. Now it's minus 12, so one of them has to be negative. I'm going to adjust that later. I know the inside 6x plus 2x should give me minus 1. Now with 6x and 2x, can I make minus 1? No. So I know that that's the wrong answer. So I'm going to go ahead and delete this and try the next one. Now, erasing this thing is a bit of a pain. So here's a little technique, if you like, to do this trial and error in an organized fashion. So I'm going to put my green, my green bracket on top and my red bracket on the bottom. So you understand what I'm doing. And then I'm going to put the number here beside to give it a try. So 6 and 2. And then I'm going to check. Now when I multiply this 6 times x, that's the same as multiplying this 6 times x. And I'm multiplying this outside, it's like cross multiplying. So I'm going to add a little cross here to show that, to remind myself that I need to cross multiply to get the middle term. In this case, we're looking for minus 1. So then I check 2x and 6x. Can I make minus 1 with 2x and 6x? The answer is no. Therefore, that's the wrong one. So you're just going to delete it or erase it. And then I'm going to say that's not good. So I'm going to try another one. Okay, actually, before I do that, this is x and x. So if I put 6 and 2 or 2 and 6, it's going to be exactly the same. But if I had 2x here and x, if I put the 6 there or if I put the 6 here, it's going to give me a different answer. So I need to check also with 2 and 6. In this case, because I've got x and x, it doesn't make any sense for me to check. So I'm going to check the next ones. So I'm going to check with 12 and 1. Because 12, I should have made that red. 12 and 1. So with 12 and 1, can I actually make so that this becomes minus x? So I'll try. So x times 1 is x, and 12 and x gives me 12. Well, with 12 and 1, I cannot make minus 1. So that'll be like saying this is a 1, and that is a 12. And when I expand it, 12x and 1x, I cannot make 1 plus 1 minus to give me minus 1. So that's not going to work either. So I have to erase it here. If you have a good eraser and a good pencil, you can do this thing, but this would go faster. And then lastly we check, okay, what if it's 4 and 3? So then I will cross multiply 3x and 4x. Well, with 3x and 4x, can I make minus 1? Yes, as long as it's 3x take away 4x to give me the minus 1. So I want it to be take away 4x and add 3. So there's my bracket, x plus 3 and x minus 4. Okay, once we have that answer worked out, we'll double check it one more time. So we're going to say x times x gives me x squared. 3 times x, minus 4 times 3 gives me the minus 12. And now I'll check the middle term. So minus 4x plus 3x gives me minus 1. It checks, I expanded it in my head. I know that this is definitely the factored form for it. Now, that was a very long explanation. Let's see if we can do it. One example, a little shorter. So if you want, stop the video right there and give that a try. If not, let's do it the long way. Again, I'll show you a shortcut in the next video. But if I have this, I know that I'm going to have x and x. There's no other choice because I have x squared. So that's good. So I'm going to have my x on top, my x on the bottom. I'm going to show that I'm going to cross multiply. And I need two numbers that multiply to 21. Well, it's going to be 7 and 3. Or it may be 21 and 1, but I'm going to try this first. So with 3x and 7x, can I make 10x? And the answer is yes, as long as they're both adding, right? If I add them, then that works. So I'm going to check x plus 7, x plus 3. And that should be my answer. Again, I'll just double check again. X times x gives me x squared, check. 7 times 3 gives me positive 21, check. And now 7x plus 3x gives me 10x, and that's good. So we guessed the right answer on the first try, and that's great. Let's get another one. 2x squared minus 8x plus 8. And I noticed something. Now, this is no longer a simple trinomial because I have a 2 in front. And this should be x. So if I have 2x squared, then it needs to be 2x and x as opposed to just x and x. But I should not forget that the first thing that we check for is to check that there is common factor. Is there a common factor in this expression? And you clearly see that yes, you can take out a 2. So you got first thing is take out the common factor. You have the 2x squared minus 4x plus 4. Now that 2 is going to stay. So we're going to have 2 and x squared, so that's going to be x and x. And I need to factor just the stuff that's in brackets. So I'm going to do the same trick. X and x, cross multiply. What numbers do I get to 4? Well, I'm going to try 4 and 1. So 4 and 1. Now cross multiply. 1x and 4x. With 1x and 4x, can I make minus 4x? The answer is no. So I get to move on. So 2 and 2. 2 and 2 gives me 4, right? So now I check. With 2x and 2x, can I make minus 4x? Yes, as long as both of them are negative. So minus. So we're going to have minus 2 and x minus 2. That's an x. Let me write it nicer. Nope. And I notice that I'll check. X times x gives me x squared. Minus 2 times minus 2 gives me plus 4. And then minus 2x gives me minus 4. So that's right. But I had to go one more step because these guys look exactly the same. So to do it properly, I need to rewrite one more last step. That's going to be 2 x minus 2, and we say that's squared. And that would be our final answer.